Hello everyone, Adam Warfield here, and welcome to Pokécheck Sprint 2. So for those of you who do not know, Pokécheck is a hack checker for the competitive Pokemon community that I have decided to make for my IST 361 project this semester. So we are just going to jump right into my goals for this sprint. As you can see, there was a lot of focus on the back end with creating the database this sprint. So the first goal was to create the database and essentially just make the table structure. And then I used that table structure to populate the database. I was able to utilize a few tricks to get some of the data in there in mass quantities, namely CSV files. And some of it I chose to do manually so I could keep track of exactly what was and was not going in and how the data was relating to each other. And then finally, I wanted to connect the database to the application, mainly for some testing purposes and to make sure everything was functional. However, I failed to do so. I wrote a method to try to establish a connection and just essentially test and see if I could do just that. And every time I ran it, it would spit out an error that I had an invalid URL for my database. However, I double-checked the URL, made sure that it lined up with the URL in my database, and no matter how many times I went over it, I could not find any error in it. So at the moment, I'm not exactly sure what the issue is with that, but it will be my first goal for the next sprint to get that patched up. Okay, so now we are just going to hop over to the user-facing demo. So this is Pokécheck in its current form. Despite the focus on the back end in this sprint, I still did add a little bit more functionality to the application. I'm still using this tab view for navigation between the two panels in existence currently. This panel is still blank. I will be getting to that in a later sprint. The main panel here, the checker panel, as you can maybe able to spot a few differences. First of all, we finally have some Pokemon. Since the database failed to link in, I just manually populated this for some testing purposes. In the future, this J combo box will be utilizing the database to populate. But for now, I just had to settle with manually putting in a few options. Also, you may have noticed the sprite changes here, much like the ball cotton sprite. You will see later it is essentially just the same method of doing that, just with a little bit different syntax to give me the desired result here. You may have noticed a small bug when I changed that. If you watch closely, you can see this move. That's because the panel is actually growing and shrinking because these GIFs are different sizes. That's a small bug I will be looking to patch up in the future here. But for now, we are just going to live with it. There still are not abilities or moves. Those are dependent on the database because of the way that they are going to be populated. Basically, the select is only going to display moves and abilities that are directly associated with the Pokemon. This will make things a little easier when writing the rules because I won't have to worry about illegal moves or abilities, as users will be able to verify if a Pokemon is legal by comparing the moves in the game to the moves available on the list. And then finally, we added in a level select. There's a bit of oversight on my part last sprint, not having this as a feature. Level is a very important factor in determining whether or not a Pokemon is hacked, so there must be a way to set this. Currently, it's just a text field here. You can enter anything. You can even enter letters. However, if you enter something that isn't an integer and you hit check Pokemon, it's going to crash the application currently. I have to add in some error handling in the future here. But finally, I will show off the biggest functional change from last week. So you can select the Pokemon now, put in all the information that's currently available. We'll go level 5. We'll do 50. And you can even select these. And then when you hit check Pokemon, it's going to spit out all the information that you have just entered up here, down here. Now, I chose to do this. This is not something that will be a feature of the application going forward. This was simply for testing purposes. What happens is when the application opens, the Pokemon is made just with the default settings that are up here. So, before you hit the check Pokemon button, it has to update to run the check effectively when all the rules are in, because you want to run the most current information in here against the rules, because that's what people are going to want to be checking. So I got the application to a point to right before the actual hack check would be run, where it updates the Pokemon when you hit the check Pokemon button. Okay, so now we are going to hop in and look at some of the code behind the application. Alright, so we are going to start off here by looking at the database. So there are currently 3 main tables. I'm working on joins and stuff of that nature to represent the data a little better. But this table is the Pokemon table. Here we have the Pokédex number as the primary key. Sprite is just a path to the sprite. That's what the view is going to utilize to change that image. And then the Pokemon name. You may notice that these 4 are the same 4 that are currently in the application. Like I said earlier, the database is not linked up. These are just the 4 Pokemon I chose to do first. So those are the 4 I hard-coded in there. So the next table is the moves table, and this table is actually already completed. As you can see, there are 719 total rows. There's a lot of moves. I didn't manually do this one though. I just used a CSV file to populate it. To do this, I actually used a tool called sequelizer.io. It's very, very handy. Essentially, you just click CSV file, browse, choose your file, name your database, and it gives you the SQL you need to create that table and populate it. I actually already had the table created, so I just took all the insert commands and pasted them in here, ran it, and I had all my moves in here. It saved me a lot of time. And then onto the final table. This is the ability table. Currently, I'm just doing these as I go along with the Pokemon. So these are all the abilities that would be associated with these 4 Pokemon. Like I said, I had to work on some joins to represent that properly, but this is where the database stands currently. And now we'll hop over to some of the Java code that I did this week. Alright, so we're going to start by showing the Pokemon class here. You may notice that there's a bunch of variables right here, and these variables line up with the selection fields in that main hack checker view that I showed earlier in the demo. Essentially what this class is doing is just laying the framework for what Pokemon is. So here we're passing all this information into the Pokemon and then just initializing it down here. And then basically we just have a lot of getters and setters for the information. So this class is overall pretty simple. So next we are going to hop over to the view. So much like the Pokemon class, I added a lot of getters and, well, mostly just getters here. There's really not too many times where I have to set information on the view. One of them, though, is down here where we set the results pane text. This will be how we display the results in the future and how I was displaying the test code of the, well, not the test code, but the updated Pokemon variables and making sure that they were behaving properly. So also in here we have the action listener that updates the spray as seen earlier. So we just add the action listener. Well, this says when this action is performed on the Pokemon select, we have this array list that just has the image pass. We get the selected index of the Pokemon select, and the array that populates that runs parallel with this array. So we just use that integer to get that file path, and then we just set it down here, repaint and revalidate to make sure things are displayed properly. So next we are going to hop over to the controller. So there's still not too much code here in the controller, but it does what it's supposed to. So when we start up here, we pass it the view, initialize down here, and then here we are adding the check button listener to the view with another call to the view here. And then we are creating the Pokemon to check. This is created with just the default selections of all the fields when the application opens, and then we are passing that to the model. So then here is what updates the Pokemon that we are checking when we hit that check button. So we are implementing this action listener, and so we are passing the information from the view to the model here of all the information of the Pokemon. And then we are getting that updated Pokemon back from the model. And then here we are essentially just getting all that information about the Pokemon to make sure that updated properly and putting it in that pane and then just revalidating and repainting again. So now the last thing we have to look at is the model. So here we just initialize the Pokemon to check, and then this is the code I wrote to test and see if I could get the database connected. Here I just deleted the password so I don't show everyone it. But I'm not sure exactly what's wrong. The error was associated with this URL here. And we just pass it all this information. I will be working on that next sprint, as I said, trying to get that ironed out. So there's not too much going on here in the model. This is the method that just creates or updates the Pokemon. Here we take in all the information, and then we set it down here, and then here we return the Pokemon, and that's essentially all the model's doing. Later when we add in the rules, it will play a big role in that. But for now, that will be it for Sprint 2. I look forward to seeing you all when I report back in Sprint 3, and I'm very happy with the progress I made in this sprint. Thank you for watching.